Hello and welcome to a new episode of I. Lots of time has passed and I can finally continue with the spinner. I won't bore you with the information about why there was a delay. I just wanted to make a new video with my progress so far. After selecting the mouse, I had to design a case for the mouse, spinner, wheel, and buttons.
The next thing I want to do is replace these buttons or remove these buttons and wire them to another mouse that's going to be located next to the spinner. I want to have two buttons next to the spinner on my board. We're going to destroy one mouse with a trackball, and these Hewlett Packard mice make the easiest sound. It's like all three. I like this one, so I'm going to destroy this one or reuse this one just for the buttons because it sounds really good. If you compare it to this one's more noisy. I don't want a noisy mouse, and it's ugly. Black's a nice color, so we'll go for black for my design. And we're going to destroy one because it's trackball. Trackball's old school. You can't do anything with it. I can use it for old computers, but I already have my old track mouse. We're going to open this one up and we're going to see if we can unmount certain parts. So we just want to keep this part, actually. Maybe even lose the wheel, or just keep the wheel for aesthetics. I don't know. Also have to clean it, by the way. Yeah, this is the one. Most of the time they are stuck here on this side. So whoa, what is this? Dust inside the mouse. So this one pushes to the trackball here on this side to keep it in place and pushing against the wheels. So that was that one for, and it also cleans the mouse. Yeah, a little bit. You can see here these dust rings. They gather all the dust from the ball on the wheel. What I want to use are these tiny switches, and underneath this ball, oh, here, that's the switch for the wheel. So when you push the wheel down, oh, we push the wheel down. Yeah, that's that one on the left. So what I want to do is connect this switch all the way to this one. Connect this switch all the way to that one, and then maybe that one too. So we even have 3 switches. And I don't know how I'm going to mount this in that case. I could cut off half of it. I don't know yet. If we take it out, let's do it like that. So we only need 2 to 3 wires for each switch, and we want to move these over to the other mouse. So we have 3 buttons, but I want to save as much of wires as possible. I want to connect each connection to a wire. Zoom in. Each switch has three, 1, 2, 3, these three connections, but they all have something in common, and that's the common. So we only have to wire that one once. So let's check. It's this one. It's the common. To that one. Down around the corner, all the way around the pins, back up to this upper one. So these three, we can use one wire for that. So it leaves us with 1, 2, 3, 4, 5, 6 other wires. Then again, there's one wire that does absolutely nothing. It's probably on an island. Here it's this one. Here it's this one. I guess here it's that one. But I'm not sure. It looks more like it's this one. So this switch is different. Hey, now I see something else. That's very interesting. Here it says Logitech, right? And this mouse, here it says HP, even on the plastic cover. So it uses a Logitech board. Haha. Then I call it a Logitech mouse. Nice cover up. I'm just going to use this wire. I'm going to write down how I should connect it. I'm going to make another drawing. This is right mouse button. We do that one first. RBM. This is going to be our common. It will be plus or minus. We'll have to see. Doesn't matter. This is push button. And then we have one that's don't care. So I'll say that one. And if we push, it will go that way. And this will be our signal. So we have 1, 2 wires. Then we have the middle mouse button. Let's call it wheel mouse button. Also, let's draw it like that. Again, that one doesn't do anything. And then we have left. And I also think I'll do it the same way. But this one has some kind of connection. And this is 4. So I could use just the 4 wires. Or not. We'll see. So this common, we have to connect it to the new mouse. So this is the ball mouse, gonna call it. And this is the USB mouse. And here's what we're gonna connect it to. And then, yeah, we'll have to see where we're going to connect this. Okay, for every switch we need to know what does it need or what does it use. And we have the circuit. Turn it around and we're gonna measure it with this. And like that. It's very simple. Every time it's the upper one and that one. I'm going to press it down, it's 0. It has some kind of diode, because if I do it the other way around, now you get the resistance, yes. So we got to do it like this. We power it from this side, and then we press, and it's 0. Same with this one. Press 0. We're going to connect this one to a wire, and then this one, this middle one, and this middle one. We have that mouse wire, so we have 4 wires. This thick cable will be our positive, and the other 3 are the 3 switches. 20 centimeters, about this size. It's more than enough from the buttons to the mouse, the other side. The inside of a mouse wire cable, it has actually a thin shield as well. I didn't know that. And this is just of a simple ball track mouse, an old school PS2 ball track mouse. This goes around this, and then it has even 2 strings, maybe for sturdiness, 3 strings. And then we have 1, 2, 3. And this one is the shield. This line, this is the copper wire.
I'm going to add solder to all the wires for easy soldering. I first tested with just one switch.
Oh, what a mess.
I tested the USB mouse with the switch parallel over the other switch. Unfortunately, I lost the video of the CRT where you can see that it does work. This is what I had in mind. This is a cross section of the case. On the left is the spinner with the mouse underneath it, upside down. The wire for the button goes to the right, and the wooden button will press down on a single switch. I can always add 2 more buttons. I want to be able to shift the mouse optical sensor a bit to change the sensitivity. The USB wire to the computer will be on the left. I'm going to check if I have some leftover wood that could serve as a nice top layer. I found 2 nice pieces of wood. I'm going to use 2 bearings to make the spinner spin smoothly. I'm also putting a ring or 2 in between the bearings. The wood is thick enough to hold both bearings. I have a brown peanut butter bottle cap, and it's going to be placed around here. Here I didn't know yet how wide I wanted the case to become. The best thing is to just do a practical test by placing the plate on your lap and find out what feels best. The width will be 32 or 36 centimeters. Two markings One on the right is for the button and the one on the left for the spinner. Time to drill a hole for the spinner. Mark the size of the hole for the bearings. The bearing almost fits, so I need to remove just a little bit with a file and some sandpaper. I want the size of the button to be large enough to be pushed by my finger. The button will be made out of wood as well, and I want it to sit freely on top of the switch. That's why I'm drilling holes under a small angle. Two on the right and two on the left. The holes are close by on the front and far apart on the back. I made a template with some tape for the size of the wooden button. I stick it over the piece of wood that I'm going to cut out. This is the button before I shape it to fit underneath the top. I have to cut off the edges diagonally on the right and the left side. I later found a dark blue bottle cap that I decided to use. I put all kinds of metal inside the cap and stick it together with hot glue. The tricky part is to try and keep the bolt in the center while doing so. Refill the glue gun. Replace the bolts. Stick a whole disc on top of it with more metal parts. I glued another plate on top. And a final layer of some metal to finish the job. Keep filling the glue gun. More glue. Just fill up all the gaps. The moment of truth. Is it balanced good enough? It wobbles a bit. That's also because it's not screwed tight to the bearings. Let's tighten the screw and push all metal pieces together. Then stick the bolt through the bearings and screw it tight on the other side with another nut. It's a tiny bit out of center and is not completely straight on top. With some minor tweaking, I should be able to fix this. I hope. This is how the button works now. I ended up with one button for this video. I might drill another hole for a second and third button, but that will take too long for this video. Next time I need to attach a round disc on the end of the bolt and find a way to mount the mouse underneath it. Then I have to attach the printboard with the switch to the plank and connect the switch to the USB mouse and build the rest of the case to close everything up. Well, that's it for this video. I hope you liked my DIY spinner project. Thanks for watching. I hope to finish this project very soon. Bye!